right place. Changes in AC compressors. There's my cell phone. As I said earlier today, I don't answer if I don't know who it is. Leave me a VM or just text me on that cell phone. Or you can email me at dahobbs@finia.com. What in the heck is Finia? Finia is fuel, and that's what that little symbol is. That is an injector spray on its side. And that is the evolution of Delphi after it's went through some changes over the years. But our aftermarket is still pretty much the same. We teach about anything there is that we have a part on or related to. So like Teslas, obviously there's no fuel pumps on Teslas or coils, and we make a lot of that stuff, but there are steering suspension parts, and we make those. So, and they just beat the heck out of them because they're heavy thanks to the battery pack and those heavy electric motors. So we will talk about um, compressors today, variable displacement compressors. We'll have a quick review of an AC system right off the bat because it's hard to understand why you vary the displacement of a compressor unless you know, like the back of your hand, how AC works: low pressure, high pressure, cold, hot, vapor, liquid, so forth. We'll get into tips on scan tool PIDs, parameter IDs, those things that you look on your scan tool, as well as the manifold gauge set, whether you just got a standalone set of gauges hanging from the hood latch on the customer's vehicle, or you're doing it a full right way. You got the RRR machine hooked up, the recover, recycle, recharge machine for the proper refrigerant that vehicle has, and is the latest and greatest. I know it's J2788 for 134A systems. I can't remember off the top of my head. I'd have to get my notes out to tell you the SAE standard. Starts with a J, I know that, for the 1234YF, but they have their own standard as well. We'll also mention cross-contamination issues that can come up when you get two different systems, two different types of oil specifically, that electric compressors don't necessarily always like. And some manufacturers are very emphatic. They don't want cross-contamination because high voltage compressors have at times, like I said, it's rare, but they have at times had issues where it shut the system down because it thinks high voltage is leaking. It's not enough for you to get shocked, but better safe than sorry is the engineering mantra of anything in the electric vehicle world, whether it be a Prius from 2005 or a 2025 Mach-E electric Mustang. It's all the same difference. We want to make sure it's kind of like a GFI in your house. None of that is leaking. We don't have a appliance in your kitchen or your bathroom that could hurt you if there's a problem. So we'll talk more about that next month. Actually, we'll get into, and I'll give you a little description of the course we're going to be doing on next month's. Once a month, we're doing this every Thursday, whatever Thursday of the month works for my travel schedule, doing the Tech Tip Thursday. So today is the day for compressors, and we'll do something on hybrids for safety and power down methods, talk about the live dead live procedure, which is really important to know. That'll be next month on a Thursday, again at noon Eastern, and at noon, same thing, Pacific, like we're doing now. We'll get into V7 variable displacement compressor, a real world case study. And this is a really important customer. It's my better half, Teresa. Okay, you are who are watching today. You know that your better half, your spouse, if they are complaining about being hot in the summer or too cold in the winter, and you're a professional tech or shop owner or instructor, that's not a good thing. You need to get on it, all right? Because they think you know everything, you could do everything. So I just worked on a blower motor problem. That's why I was holding up, talking to my colleague and friend Agnes before everybody got logged in completely and settled in. But we had a similar case I did on a V7 variable displacement compressor. Threw me for a complete loop. We'll see if it would you too. Then we'll move into high voltage compressors. And that's going to be two types: basically. They're all variable displacement because we give them variable voltage, just like a blower motor or a light bulb. You want it brighter or dimmer. You want the blower running faster or slower. You vary the voltage. The same thing with compressors. The compressors come in two, I'll call it flavors, okay? Two methods of powering them. One of them old school, you give them three-phase AC right straight into them. I'll show you pictures of those and how to check them. And then the other type, which is what most of them are these days, unless you're working on older Toyota and Lexus models, and I think some Fords, and they were given three-phase AC. All the new stuff are given DC, positive and negative, two orange cables. They never use a chassis ground once we get above 60 volts. So if it's anything of a full hybrid, not a 48 volt, but a full hybrid system, there'll be two orange cables. I'll tell you it's DC. One of the orange cables is positive, one of them is negative. So some compressors actually are fed high voltage DC. So we'll talk about how you can check those. And then we'll get into service precautions and technician safety consider and compressor longevity. Let's get started now. I promised you that overview of AC. This is important in order to understand heat pumps, which will be coming up. We talk about Teslas and BMW and Ford. They're all running heat pumps. You got to understand AC refrigerant flow. So there's always two heat exchangers, right? And a pump, whether the pump's belt driven and variable displacement, or it's an old V2 from a Chrysler, like a Tecumseh or something like that. You know, we're talking really old compressors. You guys work on classic cars, you know what I'm talking about. And Agnes, I don't know if you get any Cuban cars, but I know in Cuba there was like an embargo forever, and they couldn't get American cars. They could get Toyotas and things. They couldn't get American cars. So if you wanted to keep your Chevy, you kept it for like 50 years. So it wasn't unusual to go down there and see a 57 Chevy that had been kept running as a taxi for a half a century. So unless you're working on really old cars, they're pretty much all the same now. All right. They've got a pump, a cold thing, and a hot thing. Cold thing's always the evaporator. Hot thing's always a condenser. We come in as an input going clockwise. Again, whether it's belt driven or electric, doesn't matter. 55 or 2015 comes in as an input as a vapor. Can't compress a liquid. Now, you've all hydrolocked or known of a hydrolocked engine. Can't pump and compress water, nor can you liquid refrigerant. So it's got to be boiled off thanks to some kind of a process with a receiver dryer and an expansion valve, an ability to shut the compressor off, or an accumulator. That's the job of the accumulator. One of them is to do the dryer responsibility, plus also bleed off any liquid before it can get into the compressor. Slugging compressors is the term that we have heard for years, and it sounds like it's being punched with a hammer, the slug term. And that's bad for the compressor. It's the same as for an engine trying to pour water down the intake or suck it in through the intake in a flood. Same situation. So as long as we're getting a cold or even warm vapor, we're going to be able to compress that and turn it into a high pressure vapor. Now, if it's a refrigerant, it may be cold coming out of the can or the 30 pounder, 15 pounder, whatever you've got, depends on the machine and the refrigerant you're using. But it's going to be cold coming out in the atmosphere at low pressure, but it can be hot when it's compressed. So I don't care if it's R12 or 1234YF, high pressure output of a compressor is always hot. It's high pressure and it's hot. Depending on where the gauge fitting is, the service port will tell you. Some service ports on the high side are right here, or maybe even after the expansion valve. But usually before the expansion valve, it's going to be a different pressure because it's been cooled than it is going to be, let's say, here. So keep in mind, know where your service ports are, and know the theory of operation of AC. And that gives you a better idea. Hey, is this too high or is this too low? Anywhere where you feel with your hand that's hot, it's going to be the high side, right? So it goes in a high pressure vapor and it's going to be condensed. I love that term. Probably some engineer got fired for being too simplistic with their terms. Condensers condense vapors to liquid. When it comes out the other end, it should be a liquid. It'll still be high pressure until it hits the expansion valve, which is a restriction. And that restriction is going to cause it to go into a low pressure state, which means it's going to get cold. The little thermostatic bulb right here with oil in it is going to respond. It's going to change that with this little diaphragm in here, going to change the opening and closing. So this is a dynamic valve that changes, expansion valve. Some are electronic. We used to cycle the compressor off and on. That was called cycling clutch orifice tube. The orifice tube was the restriction, and we cycled the clutch to make sure we didn't get things too cold. But now we use expansion valves. We use expansion valves actually before CCOT. CCOT was great if you had a nice big V8 engine running that compressor. Then when you feel the compressor completely off or completely on, it was like almost towing a trailer. Now you're not towing the trailer. People complained about that. So they came back to the expansion valve with smaller engines and then eventually variable displacement compressors. But after this low pressure cold vapor or liquid, I should say, goes into the evaporator, guess what the evaporator does? It causes the liquid to evaporate as we boil it by absorbing the heat from the cabin. And we're going to boil that refrigerant, and hopefully, if we don't boil it all, and we don't want to again try to compress a liquid, so we're going to have this expansion valve out there, and also the ability for the vehicle to shut the compressor off, and that's going to raise the temperatures back up and cause this to boil one way or the other. So that's going to keep the liquid turning into vapor. This is cold. Anywhere you see it blue, it's going to be cold to the touch. Anywhere you see it red, it's going to be hot to the touch. Why am I covering this in such detail? You're all professional HVAC techs. I'll tell you why. Because if you don't know how to teach it like I just did, I'm not bragging, but I've been doing this. I've been teaching this, writing articles, reading Max publications for 50 years. I'm 65. I was doing it as a teenager for book reports for vocational college. I was taking my last 2 years of high school. I just, for whatever reason, liked air conditioning. It was cool. So yeah, naturally, I can explain it and teach it. You get it ingrained into your head, in your heart, how it all works. Then you'll understand some of these vehicles like Teslas and Mach-E's and go, oh, I see what they're doing. I can fix this. Ladies, gentlemen, there's nothing worse than working on a car and you don't understand and you don't have that spirit of, I can do it. It's horrible. I know I've been there and done that. So, want to make sure you got this down straight because we're going to reverse the flow of that compressor. Belt driven, you really can't do that. Engine's not going to run backwards so well. But with an electric compressor, that's easy. We can reverse the flow and we will have this thing under the hood become the evaporator, and this thing under the dash become the condenser. Now that's great for the passengers. Now we have with an electric vehicle that doesn't have heat from hot coolant because it has no engine. We've got heat for the passengers, and we got cold air for the passengers if we go the conventional clockwise route. That's all good, done. Well said and done. However, there are other things that need heated or cooled depending on what those things are and the temperature of the environment. Battery pack being the big issue. So reversing the coolant flow is called a heat pump. And we'll talk about chillers and octovalves before we're done with this hour. All right, so let's go past that to some animation. And I've had this for decades. This is an old variable displacement compressor. This is one of Delphi's, actually, a Harrison Radiator division that was part of Delphi years ago. And you notice the shaft's kind of wobbling. I look at that animator and I go, well, okay, that's going to make a buried noise. But that's not the point. We're showing how this wobble plate, I believe this style is called the wobble plate. It kind of changes position to a lot of displacement we're seeing there to watch this. Hardly much movement of these pistons right there. Now you'll see a shaft, and what you can't see unless you take one of these apart sometime is this wobble plate has a brass bushing right here. Now this dates back to CCOT days. They had some of this style compressor that maybe didn't have the variable displacement function, but it still worked like this. And you'd see brass inside the orifice tube screen. I'll sometimes plugging it up. You see some black crap as well. That's from the pistons. That's the graphite from the piston sleeves or rings, whatever you want to call them. But the brass, where the heck the brass come from? Brass come from that bushing right there. So this is a variable displacement compressor. It is self-regulating. We'll talk about that as we come up. And let's see if I can change slides now. There we go. Now here's the newer style variable displacement compressor. Again, an old Delphi compressor that we have developed, engineered, and sold in the past. Now I think we have a few parts in our boxes still in some of our customer shelves. However, Mala has bought most of our AC business a few years ago. So if you get a Mala compressor, actually probably is a Delphi design if it's for some of our OE customers in the past, like General Motors. So we're seeing a variable displacement here, a little different. Instead of a swash plate, I believe this is called the wobble plate. I may have that backwards, but irrelevant to the terminology, you're not really going to take them apart and rebuild them, most likely. Some of you may be a rebuilder, I don't know. But there's the pistons hardly moving at all. Now they're moving quite a long distance. So what causes that is typically in this style of compressor, in the side or the back of the case, there is a solenoid, or sometimes called a regulator valve, but it's usually an electric solenoid. And that's going to be able to let that PCM work with the HVAC electronics and decide how much displacement do you really need. Think about it. If it's not a really cold day, you don't really need a lot of refrigerant movement. In fact, if you had a lot of refrigerant flow, it could be actually detrimental. So then you're kind of wasting energy pumping on the refrigerant only to have to, work hard to boil it off, change the evaporator, the TXV, the expansion valve, all these things, maybe even cycle the clutch off and on in order to prevent compressor slugging. So just control the displacement. That also allows you to have a hard working compressor when it's super hot, a lot of displacement. And then when you don't need it all, less energy to turn the compressor. Like right now, not much energy to turn that compressor. That allows you to have less drag on the belt, more fuel economy. But also, as almost as important, the customers don't feel this gradual change of displacement near as much as they felt the compressor shutting off and then re-engaging with cycling clutch technology. All right. So let's move on from there to what makes all this happen. The magic is with these solenoids and valves. So here's a self-balancing variable displacement compressor valve. You can see some passageways and some O-rings. This is something you can be removed, but I doubt if you're going to find parts for it on the aftermarket. I'm guessing there's some progressive, maybe like GP. I forget what that even stands for, but I know they are a regular uh, vendor there at the Max Trade Show. And actually, I just seen a part when I was looking for my blower control module. I saw that GP had one on Rock Auto. So I was just trying to find good price on one, and I actually went, you know what? I'll just get one for my WD that I've dealt with for almost half a century. I mean, when the guys come that own the place to your father's funeral, that had bought so many parts over the years, that started a shop and well known, and that was my dad, Ray Hobbs. You kind of want to give them loyalty back. So I hope you do that with us with Delphi. We've been good for you with fuel pumps and coils and all kinds of other components that we're still selling. We do good for you. You return it back with loyalty to us. On the bottom, we see the evolution of these valves, and it's called an electronically controlled variable displacement compressor valve. Now you'll see these in Toyotas and General Motors and Hondas. I mean, they're everywhere now. And typically, it's going to be able to control either the compressor to a zero displacement or a near zero displacement. And that's a benefit we talked about of fuel economy and drivability and so forth. But what is the resistance of these things? Since we do have two terminals, it's a solenoid, like a fuel injector or an EGR solenoid. It's all the same. It's a winding. So you can use your ohm meter on it. You can use your ammeter. In fact, we'll see in a subsequent slide where we have scan tool parameter ID, PIDs. Toyota likes to use the term amps, amperage of that control valve, as opposed to duty cycle, which a lot of other manufacturers just put duty cycle percentage. So here's kind of the inside of one of them. So ball valves and rods and cones and so forth. I guess if you're engineer, how stuff works is nice to know. But as far as what we need to know as technicians, we need to know basically how it works in the system, not how it works internally. And there's another picture of the electronic version. But obviously, having a couple terminals here, we're going to have a resistance in the winding, and that's something you can measure. And that's what we're doing right here. So there's my fluke meter. I'm on a Ford. I think it's a Ford Escape. And so the digital multimeter, I'm testing a control valve on the back of the compressor at a connection not far from it, actually. And I'm back probing into that connector, and I'm seeing 13.2 ohms. Now, if you did the mathematics, and this was what's called an ohmic load. Now, light bulbs are not ohmic. Fuel injectors, most solenoids, like fuel injectors, they're all solenoid category, typically are ohmic. That means they kind of follow Ohm's law. So if you turned it on and left that solenoid on, and you had about 13.2 volts of system voltage, which is not unusual, 13, 14, 15 with the engine running. Let's just say 13.2 to make the math easy. Volts equals amps times ohms. Don't need to bother to remember Ohm's law, gang. It's nice if you memorize it. It's cool. But I always tell techs that are my students in my classes, just get the app on your phone. I mean, Agnes is down there in Puerto Rico, and they use the metric system as well as every other country in the world except the United States.
Actually, we use the United States. We don't
You
use
are,
metric.
yeah, you're part of the United States. I thank you for correcting me on that. But do you use there in Puerto Rico, do you use a metric system exclusively? Like the speed limits, are they kilometers per hour? Or
No,
they
we use miles.
you'd use miles.
Yes.
So we could consider our fellow Puerto Ricans, you're not only our countrymen, but you're also fellow rednecks that are behind the times, like people in Indiana, Michigan, or wherever. We still use that English system. Nobody else in the world uses it.
No.
Everybody uses metric. I don't care if you go to
Yeah.
Japan or you go to Indonesia or Italy.
We
Everybody's on
use
the metric. Cuba,
no.
you name it. Probably the Bahamas, metric. So,
Yeah.
um, like the metric system, I have an app on my phone if I want to convert stuff like that, millimeters to inches and things. I don't bother remember the math. I did it in high school. Why why try to fill my head with too much stuff? Same goes for Ohm's law. Get the Ohm's law app, folks. If you don't have it memorized backwards and forwards, and you'll know that you could put two numbers in and find out what the third is. You know the amps and the volts, you can figure out the ohms and so forth. In this case, we know the ohms is 13.2. And if volts was 13.2, it would be exactly 1 amp of current flow. Now, here's the question to you. If you want to post it in the chat, that'd be awesome. See if you're paying attention. All right. Oh, thank you, Agnes. You put the J standard for the our machine for 1234YF. That is the 2843. I probably should memorize that, being a trainer. Now, on the Ohm's law, if it drew 1 amp, if you turned the solenoid on and left it on, what would it draw if you turned it on half the time and turned it off half the time? A 50% duty cycle, which is not uncommon. That's going to give us a middle of the road movement of our variable displacement compressor. How much current would it draw? If it draws 1 amp, if it's just turned on and left on, you could say the same thing for an EGR solenoid or a fuel injector. How much current do you think it would draw if it was on half the time and off half the time, a 50% duty cycle? Go ahead and post the answer in the chat. I'll give you a few seconds here.
I think that somebody posted half an amp.
Perfect. That's it. All right. You're a fellow trainer. All right.
Actually, it was somebody else. I'm just reading the
Okay.
chat. I'm
Excellent. I didn't
sorry.
see that. Yeah, no problem. All right. Let's go ahead and go past that and look at well, we're going to go back to that thought in a minute. Talking about equipment, if you want to activate that solenoid and see the changes in pressure, that's why I have the pressure manifold set on the right, and you got the same thing built into an RRR machine, which you should use to be compliant with the AC 609 standard. So I encourage you, and it's not just encourage you, I'm going to nag y'all. If you've not got your 609 certification, you can get it online. It's not like ASE, most ASE tests. Now, ASE XEV1 and XEV2 are exceptions. Those are the ASE tests for high voltage safety. Level 1 is for just the person that maybe moves cars around the dealership, just an electrically aware person, if it's a high voltage vehicle like a hybrid or electric vehicle. And then the EXV2 is for the person maybe working on the vehicle. They're actually not hard. You should be able to ace both those tests after you've had our Tech Tip Thursdays on in May and June, part 1 and part 2. But that's something you can do online and study and research while you're taking the test. Normally with the ASE test, you can't do that. It's the same way with the 609. You can take it proctored with an instructor, and usually most instructors will help you make sure you're going to wink, wink, pass the test one way or the other before you leave that classroom. And that's actually kind of nice because the instructor will give you lots of good AC tech tips to help you know more about working on air conditioning systems. But if you just want to get the 609 knocked out, just go online, pay the 20 bucks, whatever it is, 25 bucks, get it from either ASE online or MAX, Mobile Air Climate Society, and basically study the prep a little bit, and then you can research. I have dual monitors. I can research on one monitor and take the test on the other, and you will pass. So it's really something you got to do. It's not hard to do, but to be legal, you need to use this on the vehicle. As I mentioned in the first session, if you just use a set of gauges and a can, and my friend and colleague and actually a former Delphi instructor, Pam Oakes, another Max board member. She just wrote a great Max service report about those cans of refrigerant that they sell, at the big box stores, at the farm stores, at the auto parts stores, or at Walmart, places like that. Those sometimes can have some things in them we don't want in our customers' vehicles. And unless you're doing it for your own vehicle, if you're doing it even for a discount for a 6-pack of beer, or for, your normal shop rate, the other end of the scale, it's called doing it for consideration. You're doing it even technically trading favors. Somebody gives you a 6-pack of beer, or I don't know. I got this old socket set I'll give you if you'll, charge my AC for me. I don't know how to do it. You've got a set of gauges. I saw you use it on your car in the driveway. The neighbor asked you to do it and they want to pay you. technically the EPA can come after you and fine you big time. So don't fall into that. I have some coworker and friends, not with Delphi, but another company that happened to them, and the EPA came down on them hard. So it's usually kind of a spot check thing. Doesn't happen very often, but when it happens, it can be curtains for your business profiteering, profitability, and for your reputation. So get the R machine, recycle, recover, recycle, recharge. That's the proper way to do it, not just adding the can and topping off. That being said, these gauges, either way, are going to show some things that may look a little different on variable displacement compressors versus non-variable displacement compressors. And that includes electric compressors because they are variable displacement. So whether you're using just a simple gauge set for a quick check of pressures or the machine, like you should, you got to know this. And you got to know that also you can sometimes, with bidirectional commands, change the compressor displacement. So I've got a picture of a Snap-on Varus, very good scan tool, Autel, whatever you have in your shop. Yeah, there's no scan tool I've never fallen in love with. They're all great. They have different strengths and weaknesses. We could talk about different scan tools all day, but nothing beats, I should say 9 times out of 10, nothing beats the factory tool. And that's why I've got the Cardac 3 Plus. I own one, whether it's the 3 Plus or the 4, whatever the latest and greatest is. This is a J2534 universal pass-through. So it's what a lot of the mobile techs use to program modules, but you can also use it with software from the factory, like the YTech 2.0 on Stellantis vehicles, the Jeeps and Chryslers and Dodge and so forth. You can use it for Ford, for IDS or the FDRS, the newer system, and for General Motors with the multiple data system, MDS and so forth. So Toyota TechStream works great with one of these. The thing is, you may have to have multiple laptops or multiple partitions, bootable partitions within the hard drive of your laptop, or there'll be, I'll call it nerd clashing. Nerds as in Revenge of the Nerds, the software folks, and clashing as in stuff doesn't work in great compatibility. So when you have Ford trying to work with Mazda, for example, you go, wait a minute, didn't Ford own Mazda? Well, they had a percentage of interest in the company, but the two software for Ford factory scanning and programming and Mazda cannot reside on the same hard drive. They just don't get along in the sandbox together. They're like those two kids that can't ever get along. So keep that in mind if you get into using factory scan tools through a J2534 pass-through. But it will sometimes do things that the Snap-ons, the Autels, and other brands of aftermarket scanners out there can't do. And one of those biggies is bidirectional commands. All right, so here we're looking at a couple gauges. On the left, the high side and the low side. High side on top, HP, high pressure, LP, low pressure and bottom. And there are little different numbers between the left and the right. So what's going on with that? Well, this is the same R machine, and it's the same vehicle, but the variable displacement compressor was being changed with a manual tool we'll talk about here in a minute. So we're seeing full displacement at about 225 psi on the high side, and we got a nice cool 28, almost 30 psi on the low side. We start seeing in the low 20s, you know you're going to get freeze up in that evaporator, and that's not good. And that's oftentimes, ironically, because the system's a little low. And when the system's low, not out, not empty, but a little low, low side will be a little low too, and sometimes a little too low, because for every degree of pressure, of temperature, Fahrenheit, there we go back to that old English system. In some ways, I still like it for this reason alone. About 30 degrees Fahrenheit is about 30 psi on the low side. Love that. Not so much on the high side. Then we get a little bit of algorithmic changes between, 225 degrees. Obviously, I don't think I've ever put a temperature sensor on a high side and measured quite that much temperature, but it is hotter. It's hot enough you want to keep your fingers on too long, but I don't think it's 225 degrees. But it is 225 psi and definitely warm. Over here, the air conditioning compressor is at a lower displacement, and we're running 160, 170 on the high side. And look at the low side. It's not that low because the pressures both go up. So we're a little about 62. Now, a 100-degree day, 62 feels really nice. It's not going to make your evaporator sweat that much, or maybe it will because condensation is condensation. But it's certainly going to make you feel cooler. We're looking for that 30-degree drop. 40 is even better. But a 30-degree drop on any temperature, ambient wise, feels better than just having the windows down. That's for sure. So we're looking for that, and we probably would get that. But in this case, it's because the compressor was put into a lower displacement mode. So normal duty cycle on the right, and then high duty cycle on the left. That's why that went higher and the low side went lower. And then when we went to a normal duty cycle, this was on a hot day, we're at 160 or so, 170, and about 62 degrees. That's without using any kind of tool, bidirectional scan tool, or a tool we're going to show next, like this guy. This is Four Seasons. I think they still make these, and there's a zillion pigtails. What you do is you hook up to power and ground to the battery. That powers the tool up. And in this case, it's got all these pigtails. Now, the vehicle I want to use it on, I didn't have the pigtail, Murphy's Law, so I had to use a universal one of my own. So I may have got disgusted and got rid of that. But for most cases, this is the cat's meow. This is going to do a great job. You connect it between the input and the output of the harness that goes into the back of the compressor on that variable displacement valve. Here's the Ford version. This actually was made by this company, TTC, Techno Tool Corporation. I think they're out of Atlanta, the same as Aircep. But they make a lot of special tools for Ford, and it became their special tool, the Ford part number at some point in time. You see, I've got it hooked into a Ford right now, and it works great. So you hook it up. It's got the pigtail just for the Ford connectors, and you can turn the knob and change the amount of the compressor displacement. Here's the Aircep version, where you can also up and down the duty cycle on that 10 to 15 ohm solenoid, which is going to draw around 1 amp if it's on all the time, or half an amp, like Agnes said, when it's on half a time and off half a time. A 50% duty cycle, draw about half an amp. So there's the Aircep version of the same thing. Great company out of Atlanta, make a lot of cool things, no pun intended, for the AC world, including things that make the cabin smell better when you get that microbial growth on the evaporator cores. That's a horrible smell. I've had that happen with cars I personally have owned and customer cars as well. And there's different ways to clean the evaporator. Aircep's got a really nice method of doing that as well. Here's a factory scan tool on a Chevy Cruze. And you can see the compressor is engaged. That's a data PID telling us what's going on. You can see that the solenoid is in the compressor for variable displacement is about 100% on. It's 89% on versus off. And therefore, we're seeing about 86 PSI on the high side. Now, that's a little unusual, but this is a really cold day. I think I've seen ambient temperature somewhere on here, maybe not. Anyways, so this is either a low charge or a cold day, or in some cases, 89% on. It depends on how you look at it, cup half full or cup half empty. It could also be 10% on versus 90% off. Depends on how it's looked at. But when you go to the other extreme, it's going to change that pressure. Now, here's the Toyota version of the same data PID, and they're calling it amperage. They're calling it a regulator control current, and it's about half an amp. So that spec I gave you earlier, the 10 or 12 to 15 ohms, we saw one at 13 ohms. Let's say we had 13 volts of charging voltage. The engine is running. Is when you would check this. Uh, the pressure is at 142 psi with it on half the time and off half the time. Not the compressor itself, not the clutch. It's on. I think somewhere on here is a PID for the clutch. Obviously, the clutch is engaged because what do we got for the thermistor for the fin temperature of the evaporator? 40 degrees Fahrenheit. That's pretty good chill. I'm enjoying that AC if it's a summer day. And that's half on, half off. That's why we have a half an amp. That's just what Toyota does. All right, we have a flow sensor, lots of good data parameters there. Now, case study. This is a V7 compressor, variable displacement, was on my personal Ecotech, which is a 2.4 Chevy motor. A lot of you are familiar with. However, you can almost see in the right side of this picture frame here an orange cable that snakes all the way to the front and out of this picture. You can almost see the back of it right here is this huge thing that looks like an alternator off of a school bus. Only I'm not sure I've ever seen a school bus alternator have coolant lines going in and out of it. This was the motor generator that produces three-phase AC at 130 volts. It has an inverter to change that AC. Again, we're going to talk more about this in May and June for the Tech Tip Thursday. So keep watching the website to know the date and the times. It's always noon Eastern and then noon again Pacific time. But the date in May and the date in June, get signed up, get registered, and join me. I'll be talking more about hybrids and high voltage on both those classes. But this is a light, mild hybrid, although it is not a non-lethal hybrid. It's 130 volts. Anything over 60 volts DC and 30 some volts AC is considered potentially lethal. So this is one that's 130 volts. So it's why the orange cables are orange. But that's irrelevant to this situation. Now, a lot of techs, and I understand this, when you get into technology, like for me with Tesla, I understood EVs because Delphi invented and perfected and built for many years a lot of EV components, including the Viper switch we'll talk about coming up, which is well known. It's why we are who we are. Okay, is because of innovations like this. But the Teslas, for whatever reason, just intimidated the heck out of me. I didn't understand really even how to drive them. Where to put the key. It's like a credit card for crying out loud, and how to adjust the mirrors. Everything's a little different on Teslas, and definitely diagnostics is different. Then I discovered, and you have to rent them from somebody like a Turo private owner, and then the regular places like budget car rentals started running Teslas, and I go, I like it because they're not going to turn the cameras on and watch me doing something under the hood and then call me and go, is my car broke down? I see the hood's been up all day. That's kind of creepy. So I've got a Tesla in my driveway right now doing research on it. And it's different, but I'm comfortable now because I know how to get into what's called the service mode. So we'll talk a little bit more about that in June probably, but we'll talk about a little bit about it today because it's an electric compressor. But I was intimidated by it. And so that's why I go, I'm not going to be intimidated by a car or anything else in the automotive world. I'm going to learn this stuff. If you are intimidated by hybrids, and that sometimes can just fog your mind and you can forget, it still has it. This one is a hybrid, still has an engine, it still has a belt-driven compressor. So I wasn't intimidated by that, but I was intimidated by the fact it was a variable displacement compressor. So here's the story behind it. All right. So yours truly, Dave Hobbs's wife, Teresa, she comes home one day in the 2013 Malibu Ecotech you just saw under the hood of, okay? The light hybrid, if you want to call it that, with orange cables. And she says, ever since you put a new battery in it, it's got a big high voltage battery. in the back, in the trunk, but it's also got a 12-volt battery. As we'll find out in May, every hybrid, even every EV has a 12-volt battery or something like that. But they also have the high voltage battery. But I replaced the low voltage battery, an AC Delco, regular Group 24 battery. Why? Because it was starting to go bad. It was running down and it'd been like 5, 6 years. It just was time to replace the battery. So I put a new one on. And, I got to reset the clock and maybe other things. There really no express up windows or anything like that on the car. So I go, well, I'm done. Reset the clock. I'm good. She comes home and says the AC doesn't seem to work after. So was it ever since you know that customer, ever since you tuned it up, changed my oil, rotated tires, whatever, I got this new mysterious problem. And it's really easy to get in defensive mode and go, couldn't be anything I did. But you say, hey, ma'am, sir, I'll take a look at it. That's what you should do. So that's what I tell my better half. I'll take a look at it, honey. I don't think it's got anything to do with the battery. In the meantime, in the back of my head, I'm going, well, it is a hybrid and it is a weird system. It's got a variable displacement compressor. Maybe there's some relearn for that. Who knows? So I start learning more about it. Now, if you go look at these gauges real quick, here's a better picture of the gauge right there. Okay. This is with the engine running and the compressor, click. You can hear it run, or so I thought. Sure sounded like compressor clutch engaged, and it sure looked like it with the flashlight. The engine's running at idle, and we're getting 120 on the high side and 120 on the low side. Yeah, 120 on the low side, 120 on the high side. What the beep? What's going on here? If I didn't know better, I would say the compressor wasn't running or the compressor had failed, like it blew its guts out. You ever had a compressor that totally failed or an engine that totally failed? No compression, just runs real quick with the starter, won't start. Doesn't even make that sound of compression. And so you go, hey, you need a new engine. Compressor, same thing. Need a new compressor. Or the clutch isn't engaging. Well, it looked like it was, but it's just not making a difference in pressure. Like the refrigerant is not moving around. I don't have a high side and a low side. I just have static pressure. Certainly an empty. I guess air could be in there.
So it looked like the car was with no refrigerant.
Mhm.
And well, with the refrigerant, but it was off, but the car was running, right?
Yeah, let's just say it was just sitting there with
It
the
was
engine
stable.
off,
All right.
and you hook your gauges up. This is what you'd see.
Yes, all right.
Now, this is on a hot engine. Let me rephrase that, because what would make it 120? If it was full static and you just put gauges on it and it hadn't been started, the temperature of the refrigerant would be room temperature. Agreed? As long as the refrigerant doesn't leak out into a lower pressure environment like the atmosphere.
Yeah.
Think about it, Agnes. Grab, I don't care if it's a 10 pounder of 1234 YF, a 30 pounder of 134A, or a 12-ounce can of 134A. And just pick it up. You can't tell if it's hairspray or refrigerant
Yeah.
or water.
Yeah, that's what I'm saying. It's just
Yeah.
that the car was on.
So
but
on a hot engine, let's just say maybe it was shut off and it's just heat soak. You'd
Alright.
see a number like this. It'd be 100 and something under the hood. So did I clear that up?
Yeah,
We
I
both
thought that
agree?
it was
Okay.
just you were reading it. The car was reading 120 with both sides,
Yeah.
but the
Yeah.
engine was running on, and but it was nothing. It was not happening. It
Right.
was
It just wasn't moving refrigerant. It was just a hot engine making the refrigerant hot. So it was like 120 degrees Fahrenheit and 120 PSI. So 1 degree is, until we get into the higher realm of pressure, that's when it kind of separates between 1 degree Fahrenheit to 1 PSI. That's why I guess there's still some silver lining to the cloud of Americans, including Puerto Ricans, um, being behind the times with the metric system. Because with the metric system, 1 psi is they don't use that term. They don't use 1 degree Fahrenheit. So this relationship, it's handy for text. 1 psi, 1 degree Fahrenheit. That relationship, it goes out the window with kilopascals and Celsius. So we have one advantage, you and I, over the people from France and England, including Phil Mitchell, my counterpart in the UK, is the Delphi trainer over there. I will always brag to him. You can't say that about kilopascals and Celsius. But so that we have a 1-to-1, we have a hot engine and hot refrigerant, and there's no difference between the low side and the high side. Now, let's go on to figure out why the compressor appeared to be engaged. Here to click. And I would have swore it was running and should be pumping, and therefore I should have a low side, maybe 30, 40 psi, and a high side, maybe 200 and some psi. That wasn't happening. So here it's telling us with the scan tool, this is the factory tool, that it is engaged. There's no problems, but we're only 123 degrees. So that's basically validating my gauge not messed up and that the evaporator temperature is 94. Well, no wonder Teresa's saying ever since you replaced that 12-volt battery, it's blowing hot air. She's got 94 degrees on this hot day. Now, here I have the ability to change the clutch. I can turn the clutch off and on with the scan tool, bidirectional command. I heard it click like it was running. Click off, it clicks off. And sure enough, if you looked at the front of the clutch, it would spin. You would command it either with the dash or with the scan tool, click, and you would see the front of the clutch engage and spin the same speed as the belt and the rest of the clutch. So I'm assuming it should pump. Unless, this is the part I was intimidated by, I didn't fully understand those variable displacement solenoids. Maybe it's stuck in the no displacement mode. That's a possibility, right? So I had to study up because I don't want to pull that compressor off and only to find out, oh, you can't buy the solenoid or the solenoid's not bad, the compressor's bad. I don't want to do all that work unless I know I've got smoking gun, it is a bad compressor or bad solenoid or stuck solenoid. So I start looking at the schematic and seeing where life begins to turn the compressor on. And that would be the HVAC. So the HVAC you can tell by this arrow this way and the arrow that way and a dotted line, that's a CAN bus. So that's some kind of data bus message. We just know that. We don't know if it's CAN or if it's low speed GM LAN or what LIN bus. We don't know. We just know it is a bidirectional signal, a wire, okay? So it's telling the ECM via a data bus signal, it's time for the AC to run, all right? And the ECM is going to go, well, I'll take care of that. I may need to speed the engine up to compensate for the compressor kicking on. It's still a belt-driven compressor. And I'm going to look at the pressures with the pressure transducer, make sure we're not too low, out of refrigerant, or too high, too much refrigerant. That could be detrimental to the compressor. And then if everything's good there, I'll do my job and I will turn on the signal output to the compressor relay. So there is another thing that involved obviously the compressor clutch. But remember, I heard it click and I saw the faceplate of the compressor clutch engage and spin at the speed of the belt and the compressor clutch itself. So all these functional things were going on, right? I knew that. Good ground, good power to the clutch relay, good signals from the HVAC head to the ECM, good ground over here to the compressor clutch relay, and then complete the circuit and send power to the compressor clutch. And then also, we knew we didn't have too much pressure or too little pressure, or none of this would have happened. The PCM wouldn't have let it happen. And then this is the part in green I don't know. AC compressor solenoid valve. Now, I measured resistance upstream in the harness. It looked good. And I don't think I had the ability to change it with the scan tool. I might have, I don't remember. It's been a couple years since this case study. But regardless, I was stumped because it looked like it should work and it wasn't. So I'm thinking it's just a bad compressor, or, that can't make any compression, can't pump, or a stuck solenoid valve. Either way, to get to the solenoid valve, I was going to have to pull the compressor. So I initially thought, yep, stuck valve, bad compressor. It pulled in and ran. And then I seen this. This is a smoking gun I want to talk about. So you're seeing a photo of the compressor on the engine, and I have physically removed the front of the clutch. Now, the front of the clutch, called the face plate, on some compressors, older school, typically is a special installation procedure that requires a feeler gauge, the air gap, so that it's just close enough where you can pull it in magnetically against spring pressure, because there's a great big coil in these things. You can almost see it underneath here. The great big coil that makes electromagnetic field and pulls the front of that compressor clutch faceplate in. And when it pulls in, it's already connected to the shaft here, and it spins the shaft. And that's where the pistons are on the end of that shaft. Now you can clearly see with the faceplate removed, you can see the bearing right there for the compressor clutch. And there's the little snap ring that, if you're going to remove that bearing and so forth, or replace the clutch. But you can see the screw's been removed. Actually, I take that back. There was no screw. It already had fallen out. The residual magnetism of the compressor clutch, this part right here, was keeping the faceplate, which is not in this picture, from falling off the front of the engine. That and the fact it's really close to the side of the fender well. It's a transverse engine. So you can see what happened to the spline. That should be splined so that the faceplate, when it is put in place, it will, when it pulls in with a magnetic field, it will then touch this part and the two will move as one. So this part, which is spinning all the time with the belt, will now spin the same speed thanks to the faceplate being pulled in to the front of the compressor clutch and connecting together. But how can that happen and spin this shaft if the spline is just been worn down? I don't really know. I didn't at this point care. I'm like a lot of techs. I just want to fix the car. Okay. I got other motivation. I don't want my better half complaining that after a battery replacement, I broke the car's AC. You've all been there with your customers, all right? Anything a spouse can think up, well, your customer's probably going to be 10 times worse, right? Anyways, so I thought, the heck with it. I don't care about anybody else's case study or trends or IETN or the diagnostic network. I think I might have looked some things up on diagnostic network. Didn't really see anything. Might have been a low volume problem. But that screw fell out, and that's what allowed the compressor faceplate to then slip for the course of who knows how many months or years, and to get to the point where it wouldn't even mesh because the spline was completely gone and move at the same speed as that clutch. So I was pulling the faceplate in, click. It was turning the same speed as the clutch, but it wasn't turning the shaft. If you don't turn the shaft, you don't move the pistons. You don't move the pistons, you don't move refrigerant, pressurize, and have a low side and a high side. It's the same as a compressor, just having holes in the top of the pistons. Same ideas. Or the valves. What did they call those old valves? They were reed valves on some of the older compressors. Like the reed valves are all open and we just couldn't make compression. So this was the cause of the problem. A slipping condition was not audible or visible while the engine was running. So that leads me into electric compressors. All right. So electric compressors come in two forms. The reason I want to bring up that hairy, hard to understand belt-driven compressor, if you think a new technology of variable displacement, belt-driven compressors will throw you for a loop, here's some more things to throw you for a loop. Now, again, compressors are compressors. They got pistons. In this case, it's a scroll compressor. But a scroll piston doesn't matter. It's going to have a high side and a low side because it's going to pump refrigerant. This one has 3 wires going to it. Those are AC, 3-phase high voltage AC, called U, V, and W, the 3 phases. Looks like this. And actually, you can take that cover off and you can get to those connections once you power it down. And we'll talk about that next month. And you affirm that there is no high voltage anymore. It's safe to work on it. And take the compressor off if you want to and do testing. But here's the deal. This is what the 3 phases look like, U, V, and W with a current clamp. But however, these wires are insulated and shielded. Current clamps are useless unless you make jumpers, which is a little bit dangerous. It can do it, but it's for the artist that knows how to do this. But you can make jumpers that don't have that shielding underneath the insulation. But these are special wires that are double electrically insulated and EMI shielded, so the inductive amp clamps won't work. So you really can't see this waveform. But what you can do is these IGBTs, or the Viper switches, as we've developed years in the last couple of years at Delphi, this insulated gate bipolar transistors, this is what takes the DC and turns it into 3-phase AC and pulses 120 degrees every 120, a power of high voltage between U and W, and then W and V, and then V and U. So what you can do as a technician is you can get a hold of those. I don't care if it's a 3-phase low voltage fuel pump like we make currently, or if it's a Tesla 3-phase electric propulsion motor, or a 2006 Prius, Gen 1 Prius, Gen 2 Prius, with a 3-phase compressor like you just saw a picture of, you can use this meter. This is called a milliohm meter, and it can measure more accurately than a regular ohm meter. Regular ohm meter is just going to go between U and W and go, that's 0.1 ohms. You want to see, is it 0.1 or 0.08 or 0.07? That's what you really want to see. Is there a big difference? And the specs are in the newer manuals now for electric motors. So these are called Kelvin leads. There are 2 terminals on the alligator clips with 2 complete circuits. So 2 for the positive, 2 for the negative. This is definitely not your father's ohm meter, okay? This is the other style compressor that is not 3-phase AC fed. It is DC high voltage fed, and the 3-phase inverter is built into the top of it. This represents everything from about 2010 on up in the electric compressor world, whether it be a 2011 Prius, Generation 3 Prius, or a brand new Tesla or Mach-E. The same idea. The inverter that makes the 3-phase AC is built into the compressor. So you really can't look at the phases with a milliohm meter, but you can check for leakage with a mega ohm meter, which we'll talk about next month and also in June. So this is a tool used because the compressors, these windings can have some oil from the refrigerant move past them. This was a tool that was a great idea from Aircept. So you didn't have to have two RRR machines because Toyota and some other manufacturers said we don't want our electric compressor vehicles exposed to the same oils used in a lot of 134A cars, tag oil mainly. Tag oil is hygroscopic. It absorbs moisture. And Tesla, not Tesla, Toyota, Honda, and some others said, we don't want that kind of cross contamination going on. So this tool went in series between the vehicle and your RRR machine. Otherwise, you had to purge your RRR machine for about 20 minutes, which was no easy deal, or have a second RR machine you just had for electric compressors. Now with 1234YF and some of the newer compressors that the system has PAG oil, once again, it doesn't matter. They've made a better compressor. But in the days of this picture, you needed something like this. So to kind of illustrate, as we wind this up, right? Here is a picture of a system schematic of a Jeep Wrangler 4xe. This is a Jeep Grand Cherokee, okay? Actually, a Jeep Wrangler. This is a real Jeep, okay? They're climbing hills. And you'll see here, you blow this up, and we'll talk more about this next month, but there's a place to put your meter if you know what you're doing and determine if these contactors, think of these contactors as high voltage relays. They will stick shut sometimes, as relays are known to do occasionally. And if they do, you can pull all the orange plugs and things that the older Toyotas and the older Hondas had that you want to pull, and you still have high voltage present in the system. So this is where you do a live dead live test. The high voltage is in these orange circuits right here. But see these blue wires? Those we'll talk about a little bit more in the next couple of months. Those are called high voltage interlock, HVIL, HVIL. And they are the watchdog circuits that make sure nothing's unplugged. There's no problems. Otherwise, it'll shut the system down as quick as any safety on a gun makes it impossible for you to pull the trigger. Now, as we look over here at the compressor, you'll notice it is one solid black line around it. There's a chassis ground just for shielding, but we'll see the same 6 IGBTs, insulated gate bipolar transistors, the 3-phase windings, the same stuff. Look at this heater control, high voltage heat. I'll tell you right now, that is going to kill the range. So when I say this is not like a Prius, this is not your father's Oldsmobile, it's not your pop's Prius either, I mean it. What they do with the newer vehicles, electric compressors now, beyond the Prius, beyond the Honda Insight and the Honda Civic hybrids, and those older hybrids that you're used to, they are running the compressor backwards. So now I mentioned know your AC fundamentals, like so well you could teach it. The hot thing now becomes the cold thing. The evaporator is now the hot thing. The condenser is now the cold thing. And we're going to use that for passengers as well as the battery pack. So here's the AC compressor, 360 volts. This photograph right here from Professor John Kelly at Weber State University. Encourage you to check out his YouTube channel. These are coolant lines. Battery packs removed from the Chevy Volt. The coolant lines may carry hot coolant or cold coolant depending on what the battery needs. Because the battery is the new passenger that's like my wife. Don't make her drive a hot vehicle in the summer or a freezing cold vehicle in the winter. It's not good, all right? Battery pack is not going to cooperate, give you great range and great performance and charge quickly in the winter unless it's warmed up. And in the summer, unless it's cooled down, the same applies. So thermal management with running the refrigerant backwards in a heat pump, like we see here, thermal management, I call it Rube Goldberg over complexity, 35 molded hoses on this Mustang Mach-E, the electric Mustangs. All right. And here's not too shabby of this BMW i3, lots of hoses and solenoids and pumps. Here's what Tesla has done. Simplify. sometimes that's probably, I think, really intimidated me about Tesla is the fact that they were too simple. I'm expecting complicated. They took 35 hoses and put them into eight and then had one distribution valve called an octo valve. They even put a little imprint of an octopus molded into the plastic molding on the unit. I think that's got to be Elon Musk. He's a different kind of guy, right? You hate or love his politics, forget it. The guy can put astronauts in space and rescue them back and build electric vehicles and all kinds of robots and stuff. He's a genius, but he's a bit of a weirdo too, because he puts an octopus's image on his octo valve and calls it that name. But you count these hoses, these are coolant lines, eight of them, and a rotary valve to send hot or cold coolant, depending on the movement of refrigerant and the direction of the electric compressor, and cool things down or heat things up as they need it. And this is what it looks like on an actual Tesla Model Y with a compressor that is mounted in rubber mounts and insulation all over them, because they can sound like a coffee grinder if the engine's off. In this case, we don't have an engine. So my wife says this thing sounds like a golf cart, makes no noise. Sure, it does. And that's why the compressor needs to be mounted in rubber and insulated so you don't hear that. But there's your service ports. There's a 12-volt battery. All the electrified vehicles have those. We'll talk about again next month, the month after. These are called,
What year is this one?
oh, okay. I heard something in the background there. These are called chillers. There's a couple of them. And then this is called a super manifold. So a lot of different things that you won't notice on a normal hybrid, older vintage, or on any gas-driven engine. But this is one of the best things I love. This was a Chevy Equinox. It was a cold day. I went to do a fast charge, and when I plugged it in to a fast charger, Electrify America fast charger, the cooling fans all came on. I heard pumps and relays and all kinds of activity under the hood. I had the hood up. I'm watching. I'm just wishing, why didn't I have a scan tool with me? But in this vehicle, it said it right on the dash. It says, getting ready for a fast charging, just like an athlete, your battery needs to warm up to perform its best. In the same way, this feature gives your vehicle a head start for a fast charging. That sums it up. Why they do what they do. We'll get more into the electrification next month. You're invited back, and again in June. In the meanwhile, if you're in California and you're a teacher, make it to the California Auto Trainers Association, CAT, near the Sacramento area. It's actually coming up this next weekend, and then after Easter, and then in June the 9th through the 15th. If you're a teacher, you're welcome to come to the NACAT conference, the North American Council of Automotive Teachers, in Motor City in Detroit. I'll be teaching coil on plugs in the morning on Wednesday, and then teaching this topic only for about 3 or 4 hours in the afternoon. So check that out and come back also on the Tech Tip Thursdays. Please hang around and do the survey if you got a minute, and we'll see you on the next one. Thanks, folks.
Hey, hey. Good, Vlad. Thank you very much. What was the year of the Tesla that you presented?
That one was about a 21.
Yeah.
Yeah, I've noticed the one that I've got right now for evaluation is a 23, and I've not pulled the frunk out yet, but I had another 23 or 4 at a AutoZone conference. They were doing a booth for one of their customers at a big trade show, and I pulled the frunk out of that as a 24Y model. It did not have a lead acid battery. It had a solid state battery.
Yeah,
So that's something to be aware of. Yeah, and the parasitic current draw is a whole different world. Agnes, I noticed the cooling of the compressor working, even with the key out of the vehicle and the vehicle shut off. This
It's
is
all the time.
inside a trade show. So this is a, room air conditioned building. And I was not doing anything. The key was out of the vehicle. I had the frunk out and the hood up, and I noticed the compressor began to run, and I noticed charging voltage on that solid state 16-volt battery. They
That's
call
what
it
I
a
was
16-volt system. Yeah,
That's what I said, that
yeah,
I've seen it. That's why I asked for the lead battery, the lead acid, because I've seen the Teslas with
yeah.
the 16 valve now. And it's a whole change now how to diagnose it or even understand it.
Yeah, by the way, in a Tesla, if you get one in your shop or you rent one sometime, um, you click on the icon of the car on the dash,
Go to service
and
mode.
then you click on software.
Okay.
When you get to software, it'll say like Model 3 or Model Y, and maybe have the car's VIN number or whatever. Where it says Model 3 or Model Y,
Click it.
touch that, hold it for several seconds, 3 or 4 seconds, and then release.
It would show the
And
service
it'll
mode.
ask you for the code, and you put in the word service. That's really simple, service. And that's where you can see some stuff in animation. It's very impressive. You can see the
agree.
octo valve, you can see the movement of refrigerant, and it's how you can open and close valves and solenoids in order to do different work. Like you want to purge the system and do a complete coolant flush, or you want to do an AC flush or whatever. It's how you activate stuff. You don't even need a scan tool for most things.
Yeah, I've seen
That's
it.
pretty neat. Yeah.
I have seen it the other way, couple of, like a month or 2 months ago, I got a Tesla. And the Tesla that we see, it was low on coolant. And it was telling you it's low on coolant. It's, you
Right.
have to. And it's really amazing. It's
Yep.
really amazing.
I'm super impressed. I know I've touched the tip of the iceberg. And so between now and when I do like a 3 or 4 hour version of this class, I'm going to go more into this vehicle, get the frunk out and see more things and see if I've got a solid state battery or lead acid battery. A 23 model could go either way. But I think around 21 or 2 is when they started using those batteries. But because I'm doing a parasitic current draw class coming up next weekend after Easter in California, they're going to ask me, well, when does the Tesla ever shut off? And like my GM friend is a master tech, was at a meeting with him a week or so ago, and he says, oh yeah, the Chevy's the same way. They never shut off unless you put them in a storage mode where you shut the high voltage off and the low voltage as well.
I know that I have a Kona, and the Kona, when you plug it in, it's turned on. When you plug it in just to charge it, it's turned on if it's needed.
Yeah,
So
yeah.
they're always active.
Yeah, because they sometimes want to cool or heat up the battery pack.
Yeah.
And also, I didn't know this. So you know how you're talking about parasitic current draw, keeping a battery from running down. They will, while the 12-volt battery or 16-volt battery, whichever case may be, 16-volt solid state battery, while they are still able to, they will monitor that voltage and say, okay, let's turn on the high voltage. Let's turn on the DC to DC converter. And if we need to run the compressor, run the compressor. And the DC-DC converter will keep the 12-volt or 16-volt battery from running down. Now you lose some range, but hopefully you didn't park it with 1 mile of range, on the odometer. I have an ex-son-in-law that did that. And we're all wondering, he went on a business trip, and we're all wondering, is he going to be able to get down the street from the airport to the supercharger that's like 2 miles away? And he was able to make it, but he could only go 5 miles an hour. I think he had like 2 miles of range left on the car.
I know. Are you gonna be doing any classes on the east side?
In where?
In the east side, Florida, or even New York or something like that. Some,
I don't think I heard you. Type it in the chat so I can hear.
uh,
Where at? Well, it's quiet now. I can hear you now. Or you muted?
yeah, because it's a background over here. Are you doing the class on any of the east side? You know, the Florida or New
Oh,
York,
Florida?
or I don't
I
know,
don't have
anything.
anything. I don't have any East Coast or Florida other than the NACAT conference, which I'll talk more about thermal stuff. And then, of course, California, I'm going out to a customer's location, and I think it is June. I'm doing the class is called Hide and Seek Thermal Management because, some of the stuff is hard to see where it is and what it does. And that's why I kind of gave it a name, but it's basically thermal management for electrified vehicles.
It's a
Um,
really nice name. I didn't speak of thermal management.
yeah. Because it's not just AC or heat.
It just,
It's managing people, and the inverter has to keep cool. The DC to DC converter has to keep cool, but the battery pack may need to be warmed up or kept cool. And of course, people always need to be warmed up or kept cool. We're always picky about how we, our environment at home or in the car. It's all the same. But battery packs are just like I call it's like having a baby in the car, You got to have the
yeah.
baby so the baby doesn't cry.
Yeah. But
Keep the battery pack like the baby, not too cold or not too hot.
but thank you very much. It was a
You're
really
welcome.
nice class. I like it. I was here all
Thank you.
time.
Yeah, I will.
So
I will make sure I put future classes on Facebook. So, yeah, if you're following me on Facebook, I
I
try to do
had.
that whenever possible. So, because it's like, people say, I didn't know you were there. You were in my backyard.
Yeah.
So
So let
I'll
me
try
see
to
if I
do that.
could, maybe I could travel and see you in one of their classes. So
Yeah.
it's gonna be good.
Hey, tell you what, if you can get enough technicians in Puerto Rico to attend a class. I don't care where it is. If you want to translate it, Delphi will get me down there. If you got 15, 20, 30 techs, especially if it's, through one of our customers that sell parts, we sell
Yeah.
parts to.
All right.
That's it. I'll
I
come to
will
you.
contact you.
Or
I will
definitely
contact
get
you.
something in South Florida. That'd be work.
Yeah.
You never have to argue with me getting to South Florida because my wife loves to come there.
I know.
That's where we go on vacation, for crying out loud.
Oh, you can come here in Puerto Rico and just be with us. So
Maybe we
I'll,
could take a cruise off of Samsung. I've been promising to take her on a cruise, for a
yeah,
long time. So
it's a nice one.
we'll make
So
it happen.
I'm
All
good.
right. Take
All right.
care.
See you. Bye bye.
Bye.